Okay, so hello everyone. Welcome to Intellipaat's live workshop on artificial intelligence, neural networks, and beyond. So today's workshop will be conducted by Mr. Srinath, who is currently working as a senior manager, credit and fintech at end users Bush InBev. So he has also worked as at Microsoft as a delivery data scientist. He has extensive experience in artificial intelligence, machine learning, and analytics. So, guys, let's welcome Mr. Srinath into the session. Sir, over to you.
All right. Thank you so much for the introduction. I'll quickly introduce myself as well. A little bit of myself in a little more depth, and then we can go straight into the session. Right. So my name is Srinath. I've been in the field of data science and artificial intelligence for the past 10 years or so. I've started off my career as a mechanical engineer, and then transitioned into the field of artificial intelligence with a master's in AI. Worked at a couple of startups at the beginning of my career, and then eventually moved out and joined the corporate world. Worked for companies like Verizon, where I was almost like the first hire as a data scientist. This was back in 2013. And then worked at Microsoft for close to 4 years. Now I head the fintech division, the AI fintech division at Anheuser-Busch InBev, the world's largest brewing company. So that's and I've been teaching for almost the past 7 years or so, 7, 8 years. Yeah, and it never looked back since then. I've continued to teach. And this is a personal passion of mine, which I continue to pursue. So that's in short about myself. Let me share my screen for our today's session. The topic, of course, is about neural networks. Is about the field of neural networks, and a little bit about how neural networks are useful for us in modern day, and secondly also the application of neural networks. I think it's fair that we talk a little bit about the history of artificial intelligence, just to understand where we actually come from and why are we doing what we're doing right now. AI is not a modern day phenomena by any means, right? Artificial intelligence was first thought about and termed in the year 1955 by this wonderful individual by name John McCarthy. He is the one who actually termed artificial intelligence. At that point, the intent behind artificial intelligence, or the way artificial intelligence was envisioned at that point in time, was to basically build machines that are intelligent or smart, right? Question is a washing machine smart? Well, probably not, right? So washing machine operates based on a particular set of programs, a particular set of rules. So is it smart? Does it respond to external stimulus? Does it adapt to external changes? Probably not. And that's the fundamental difference between a smart system versus or rather an intelligent system versus any machine. A machine can do the same job repetitively numerous times, but an intelligent system can do the same job repetitively numerous times and also adapt based on external circumstances. The idea behind artificial intelligence back in the day was to build such machines which could be artificially intelligent and adapt and adopt based on external circumstances and changes in circumstances. So 1955, actually 1950 in some form was actually a pretty revolutionary year. This was the Turing test, and even before the Turing test, if you've watched the movie Imitation Game, you must have heard of something called as Enigma, which was the machine that was built by Alan Turing along with his friends, along with his colleagues rather, during the World War II to decrypt German signals that were being sent. So it was based on cryptography, and then he went on to create something called the Turing test. Basically a test for machine intelligence, right? So that's the idea over there is to evaluate if a particular machine has intelligence or not. And the Turing test was actually created in 1950s, and then things went on. The field kept evolving, right? So 1960s, 1970s, a lot actually happened. I think something very interesting is the first ever chatbot was actually built in 1964. So we all operate on we all work on chatbots today. But interesting story. The first chatbot ever built was in the year 1964. It of course had very little capabilities, but yeah, nevertheless, we were still able to build our first chatbot in 1964. We went on, and then we continued to explore in this particular area. Shaky was built basically like a bipodal electronic person sort of a thing, and almost like that had a camera and it had like a bunch of different things. We always are fascinated with this idea of having a human-like robot. So when we think of artificial intelligence, what comes to our mind is a human-like robot, a humanoid robot. That's what we always think about. The reality is that actually our structures, the bipodal structures, are actually highly inefficient and because of that, actually creating machines with two legs is you spend a lot of energy just balancing the body on the two legs and then balancing the center of mass, which is the reason why we are not as agile as probably some of the other animals that we see out there. Anyways, moving on. So 1966 was when the first electronic person was built. And then, interestingly, almost like a brief 2 decades, two and a half decades, not a lot actually happened in the industry. Of course, there's a lot of active research that was going on in this particular space. A lot of interesting revelation in this particular area happened in the in the years in between. So a lot of interesting revelations actually happened in this particular area. And I see a question over there talking about does ML also come under the field of AI? I'll talk about that in a few minutes. I have a specific slide where I specifically talk about just that part. So moving on, 1997. Again, a breakthrough year for the field of artificial intelligence. Again, what do we mean by a breakthrough year here? So interestingly, what happened here was in 1997, IBM put together an artificial intelligence system called as IBM Deep Blue, which was capable of actually defeating Gary Kasparov, the then Grandmaster of chess, which was a significant, progress in that particular field. Why? Because as human beings, we were always prided at the fact that chess is a game that nobody else could play. Human beings are actually so smart that we could do like a bunch of different things in chess and this and that. So we always like super proud about our capabilities about playing chess. Now, interestingly, it so happened that human beings were defeated by machines in 1997 itself. 1998, 9, and so on. Things kept evolving in the same area. Interestingly, in 2002, Roomba came in. Roomba started to become very popular these days in India, but Roomba was basically a vacuum cleaner, right? It now became very popular. This company by name iRobot was the one who actually came up with this small machine that can go through the nook and corner of your house and actually clean the house. It's a vacuum cleaner which has the ability to navigate itself through the maze that we have in our house, right? So you have your sofa sets, you have carpets, you have tables and chairs and all of that. So basically, to navigate itself through all of that and then yet collect all the dust of the house. Roomba was actually introduced in 2002. The company is still active and actually doing very, very well. They have improved versions of Roomba these days. And thanks to COVID, in countries like India also this became very, very popular. 2011, again, a massive breakthrough year. Siri came in, Cortana came in, Google started to bring in their assistants. Then 2010 onwards, that's where the field of AI just took off, right? Just took off and took off. Exponential development happened during these years, during the last 10 years, if I were to say. So Siri came in, IBM Watson became very popular. IBM Watson actually, this was actually a very interesting journey as well. I would suggest all of you all to go back and view this video if you have some time. Just go to YouTube and search for Jeopardy, which is like a very popular quiz competition. And IBM Watson was basically a supercomputer built on artificial intelligence that was able to beat human beings on the show and actually won a $1 million prize at the end of the competition. So it was a very, very interesting show and very, very interesting competition that I would suggest all of you all to watch it. It's on YouTube. You should be able to go back and watch. Actually, even this video is on YouTube. You should also be able to go and watch that. And then things kept going. Again, 2014 Alexa was launched by Amazon. 2016, 2017 Google Home was launched, and a lot of interesting developments started to happen in that particular space. while all of this was happening, there were like a bunch of different setbacks as well. In 2016, this was actually a pretty interesting setback. Microsoft had launched a bot called as Microsoft Tay. I can actually show you what happened with Microsoft Tay. I don't know if you're all aware of that, but I can actually show you what exactly happened. So in 2016, Microsoft had launched this bot called as Microsoft Tay on Twitter. Um, it was an AI bot, and I would excuse me for the profanity in the article here. But yeah, so at the beginning of the when Microsoft Day was launched in at the beginning, it says, "Can I just say that I'm super stoked to meet you? Humans are super cool." That's how it started to behave. And then it says, "I'm a nice person. I just hate everybody." And then it went on to becoming, "I hate feminists. They should all burn and die in hell. Hitler was right. I hate the Jews." So it went on from something as nice and as cool, with saying super happy to meet you, to saying Hitler was right. I hate the Jews. Now, what exactly happened there? Artificial intelligence is basically, what is intelligence? Right? We learn from what we see, we learn from our experiences, we learn from information, we learn from data. And when in such cases, when you have systems which is exposed to external world, like we as human beings are, then it's quite likely that machines also learn the same kind of information. Machines also learn the same kind of behavior, and which is exactly what happened here. The Microsoft Day started to behave exactly like human beings, and because of its inability to adapt and filter out unwanted content, it ended up learning all the unwanted stuff. We as human beings have the ability to we have a very unique skill called a subjectivity, and artificial intelligence at that point in time was not able to separate subjective comments and hateful comments, and for that reason it just ended up learning what it had to learn and what it was being exposed to. And unfortunately, it ended up becoming, a bot that was like this. Even in 2018, we all must have 2018, 2019, Facebook's AI also went rogue, and they had to shut down one of their AI systems because it was actually making incorrect decisions. So if you remember, there was a lot of news about that as well, around Facebook shutting down their AI. So a lot of interesting incidents happened in this area. A lot of interesting learning also that happened in this particular space during that time. 2017 AlphaGo was a massive victory. And Go is is known to be one of the most complex board games that exists out there. One of the most difficult board games. And a company by the name DeepMind actually built AlphaGo. And then eventually what happened is Google ended up buying their company, which is why it says Google's AI AlphaGo. Actually, it's not Google's AI; it's the AI by DeepMind, which was eventually bought by Google. So yeah, 2017 that happened. 2019, Microsoft built a game. Microsoft bought a company called Malibu, and not Malibu, Mariba or something, if I'm not wrong. And that was basically a company that was able to solve Pac-Man, right? So basically, win all the stages of a Pac-Man game. OpenAI was also built during these years. So a lot of interesting developments have happened during this area. Broadly speaking, what we've started to venture into was more and more complex problems, more and more human-like problems, and right now we have pretty decent systems that can actually solve these human-like problems. So today, when we talk about artificial intelligence, right? So we can broadly think of AI into two parts. One is artificial narrow intelligence, and the other is artificial general intelligence. What do we mean by artificial narrow intelligence? Artificial narrow intelligence, or also referred to as weak intelligence. It's also referred to as artificial weak intelligence, and this is called as artificial strong intelligence. And the reason why we call this as weak AI and strong AI is because artificial narrow intelligence is basically all those AI systems or all those intelligent machines that are capable of solving one problem at a time, right? That are capable to solve one problem at a time. That's what is referred to as artificial narrow intelligence. And then there's something called as artificial general intelligence, wherein you have one AI system that can solve multiple problems all at the same time. Pretty much like us humans, right? So our intelligence is capable of solving multiple things. If I learn how to, let's say, recognize colors, I also have the ability to paint. if I can recognize colors, I also can drive, because then I know which is red, which is blue, which is green. So my learning I'm able to apply the artificial intelligence in multiple different areas. Today, majority of our applications are in this particular space, where an AI that is built for a particular problem cannot be used to solve multiple other problems. But eventually, we would want to transition into an artificial general intelligence where we can have a more human-like intelligence, which is capable of solving multiple problems all at the same time. Some examples of artificial weak intelligence are these, right? So Netflix, when you watch Netflix or YouTube or Hotstar or Ghana or Spotify or any of your streaming services, you get recommendation system, recommenders or recommendations at the background. Now the artificial intelligence that is used to build those recommendations can only give recommendations. I cannot use the same AI machine or the same AI system to, let's say, drive a car. Whatever AI that I build here is only capable of doing this, right? So this does not have the ability to maybe drive a car, or this does not have the ability to maybe identify images in a particular photograph or faces in a particular photograph, or let's say find your best match on Tinder, or let's say do flight scheduling, right? So all these are different areas where you could have different applications of artificial intelligence. These are all basically trying to solve problems in some form or the other, but whatever problems that it's able to solve is very very specific to is very specific to this particular area only, and only to that particular, it's localized solutions and not really generalized solutions. And that's the biggest difference between artificial weak intelligence or narrow intelligence and artificial general intelligence. Now, a good example for artificial general intelligence, I don't know how many of you all can recollect this image. This is basically your artificial general intelligence. Basically, this image is from the movie Her. I don't know how many of you all have watched the movie Her. It's basically a movie where a computer scientist falls in love with an operating system, and the operating system is so human-like that it actually exhibits human-like emotions, right? So it expresses love, it expresses all human-like abilities, and which is where things become very very interesting with that. So what we want is something like that, or maybe a Terminator like person who can do everything, or I don't know, maybe the robot in Jackson, or Dennis the Menace for that matter. So that is what we ideally want, but yeah, the fact is we are far away from that. I wouldn't say very far, but I would say we are definitely at least maybe a decade away from getting to something like use a decade or 2 decades away from that. We will definitely see something very interesting in our lifetime for sure on that space. So mobile net, postnet, doodle net, yes, they are all narrow intelligence. Yes, they are all narrow intelligence because they're built to solve specific problems. All right, moving on. Now, applications of artificial intelligence. Now, this is you know it, right? So there is like a massive area in this particular space. There is, I mean, the applications of artificial intelligence are massive in this particular area. You start with banking, finance, manufacturing, pharmaceuticals, healthcare, and so on and so forth, right? So different these are all different applications. Every field has its own specific application of artificial intelligence. You name a particular field and I'll give you like 3 or 4 different applications of it in that particular area, right? So for example, in sports, selecting teams, identifying which player is likely to be in your team, identifying which player is likely to get injured, what is, predicting, hedging on a particular player's performance. All of that is pretty interesting, and all of that in a lot of ways is are all multiple applications of artificial intelligence. Yeah, facial recognition, Hawkeye, right? So if you're aware of Hawkeye, that's a fantastic application in sports for sure. Yes. Arduino, again, Arduino is more like, I don't know if you're talking about the same thing. It's basically like it's actually hardware than artificial intelligence. Yeah, so it's actually a hardware system. It can also have, I mean, you can also embed AI into it. It's like Raspberry Pi, if you think of it, right? So it's very much like a hardware system that can that comes with like a bunch of different sensors. You can embed artificial intelligence into it. Yes, for sure. It's almost like a chipset. Think of it like a chipset. And then you could do like a bunch of different things on top of it. You can actually turn it into a computer, and you can do like a bunch of different things on it. So Arduino itself is not AI, but you can embed artificial intelligence into it. So it's like if I give you a computer, is computer artificial intelligence? Probably not. But you can definitely do a lot of things with a processor and a CPU and solve like a bunch of different problems. And we'll talk about that, right? So when we talk about intelligence, right? So what we need to understand is when we talk about intelligence and human intelligence is often, uh, you know, a combination of different types of um, intelligence, right? So when we talk about intelligence, and I'll tell you why I'm giving you an introduction about intelligence, because it's important for us to acknowledge and understand how can we make machines artificially intelligent, and then I'm going to talk about that one field which we're going to focus on, wherein neural networks and everything come in, right? So this is basically starting from like the 10,000 feet view and then boiling this down to the most important section, right? So when we talk about intelligence, a human intelligence can broadly be classified into these five. It's very difficult to exactly say the different types of intelligence that we as human beings have. They are like multiple components, but these are like the broad five components you can think of. But just to give you a simple example, linguistic intelligence. What do we mean by linguistic intelligence? Linguistic intelligence basically means the ability to communicate via a particular language. The ability for me and you to communicate, to agree upon a certain grammatical structure of a language, and then I using a certain words, and then you being able to understand, and then you communicating that back to me. That is fantastic, right? I don't we don't know of any other, or maybe there are, but we don't know of another species that can actually communicate like us, and with that level of proficiency and with the level of nuance that we can. That is fantastic, phenomenal capability that we have. So the language is one of our biggest strengths, right? What that has helped us achieve is translate knowledge from one person to another person, transform it from generations to generations, and that has become a massive source of knowledge and learnings for us, right? That becomes like the core component of our intelligence. The ability of perception. What do we mean by perception? Of course, there are other species on the planet that can perceive better than us, but perception is the ability to see, the ability to touch, the ability to feel, the ability to smell, your primary senses that you have, right? All of those perceive a certain kind of a feeling, or a certain kind of an activity that happens out there, right? So when something is burning, you smell, so your nose is perceiving the smell. When something's happening ahead of you, your eyes capture that imagery, and what is happening is your eyes are actually perceiving the activity that is happening around you. Or when you touch something, the ability to touch, let's say your laptop, the ability to touch, that is perception again, to feel the texture of something. Very, very unique capability that we have again as human beings. Of course, other species also have those capabilities. Like, for example, I have a dog at home. My dog can hear well, can see only to a certain distance, but can hear really very well. And there are other beings, like for example, bats, which don't get to see as much, but they can hear very, very well as well. So different species have different kinds of perception capabilities. In this case, we have pretty balanced perception abilities. Of all of these, of course, we also have the ability to reason and solve problems, right? If I put you inside a room, and if I give you a stool and maybe and if I ask you to solve that particular problem, you actually find a way to solve the problem. Not just us, even dogs, right? You put a treat in a box and give the box to the dog. The dog will find a way to actually get that treat out of that particular box. That is problem solving. That is dexterity, and using dexterity to solve a problem. We as humans we're very good at problem solving, right? So we needed to transport things, we built wheels. We needed warmth, we invented fire, and so on and so forth. Right? So the point is, we didn't invent fire, we discovered fire. But point being that we again have the ability to solve problems, and our problem solving abilities are definitely the reason why we are on top of the food chain today. Right? So we can, every time there's a challenge, we find a way to solve that problem and evolve. Right? And last but not the least, the ability to learn. Now, the learning part is what separates us from every other species that's out there. What do we mean by learning? Oops, sorry, just a second. So, what do we exactly mean by learning? So, learning is the process of capturing knowledge from information that is already available with you. So, what does that require? It requires us to first log information, right? So, if there is historical books, information, data that is recorded, then our further generations don't have to go through the same experience again and again. Rather, they can learn from somebody else's experience. What do I mean by that? So, somebody, a noble person, for all of us, put their hand in the fire and realized your hands burn in fire. So, that is a logged information. How many of us today have actually put your hand inside fire to realize that fire is hot and it'll burn your hand? We haven't, right? It was told to us that look, if you put your hand inside the fire, you're going to burn your hand. Great, you've learned it. Now you're never going to do it, or you will act based upon your learning. My dog, on the other hand, is not like that. My dog probably doesn't have that level of. Of course, there is some information that is being transmitted evolutionarily generations to generations. But my dog does not have a book to refer. My dog cannot go into a library and read. Forget about my dog. Lions don't get to read, or none of the other animals. They evolve over a period of time. Genetically, they evolve, but that's about it. That's the genetic intelligence that they have as they're born. But they don't read books, they don't log information, and they don't have the ability to learn from information that is being created by someone else on the other side. That part is why we are number one today. Why, when I say we as human beings, we are number one today. Now, the attempt that we're trying to do is basically give machines all this type of intelligence. If a machine can exhibit all of these intelligence, then we can probably say all or some of them in some form. Then we can basically say that the machine is in some form artificially intelligent, at least. If not all of them, at least some of them. If a machine is able to exhibit, then we can basically say that the machine is artificially intelligent, right? So when you now take a self-driving car, right? Spare me for my drawing. Tesla is going to probably kill me for a drawing like this. But if you take, for example, a self-driving car, what do we want? You have the self-driving car basically has like a bunch of different sensors around it, right? So it has sensors all around it, and what it is doing is it is looking for what is in front of it. It is capturing imagery. If there's a person in front of it, it is perceiving that there is a person in front of it, and then using that information and then solving a problem. What problem is it solving? It is then deciding which direction it needs to go. Now, on what basis will it know which direction it should go? So it has learned from historical information that when there is a person in front of you and when there are certain circumstances in a certain way, the machine will have to act in a certain fashion. Like, for example, okay, left there is a road, right there is a valley, there's a person in front of me. So, given this situation, historically, what the person has done is the person has taken a left. So, let me replicate the same action. Right? Historically, I've seen something happen and I'm replicating that behavior right now. That is basically putting the abilities of perception and learning together to solve an interesting problem of self-driving in this particular case. So every artificial intelligence system that you take, every artificial intelligence system that you take, combines multiple of these abilities to solve a problem. Right? Like, for example, your your if you take Apple Siri, what is Siri doing? At the background, the moment you ask a question, so when you're asking a question, you're actually asking the question verbally, right? So you're basically asking the question through voice,
And what Siri is able to do is firstly perceive that. So there is a sensor which is capturing voice, converting that voice into some form of a text, using that text and then trying to solve, historically go back and find the best possible response to that particular question, convert that to back to text, into voice, and then read it out. All of that is a combination of perception and intelligence, or perception and some form of using some form of learning to solve this problem together. Right? That is also what Apple Siri is doing. So artificial intelligence is basically about building systems that can help us solve these problems efficiently. Um, Now coming to the most important part. We're coming to the most important part. Okay, great. Now, how do we actually solve these problems? This looks great on paper. Like, okay, Srinath, this is all nice and rosy, but how do you actually solve these problems? How do you provide, the kind of intelligence? How do you learn from historical information? How do you learn? If I give you a bunch of books, I can read and learn because my brain has the ability to retain information and retain some knowledge, gain some knowledge out of it. Right? So when I read a book, I don't necessarily only memorize information. When I read a book, I gain the knowledge from the book. Right? So when I learn from historical information, when I read a book, I'm not just memorizing things. My brain is not just remembering everything, but what my brain is doing is it is trying to combine, it is trying to extract some interesting patterns from that particular book, interesting themes from the what the book has to say, and remember those themes and not necessarily just the book or the lines of every line in that particular book. That's not what my brain is doing when I read through a book. So how do I, given a particular machine, then how do I pass some additional information to it and then get my machine to learn that, hey, look, this is how you need to react? How do I tell the machine, when I say machine in this particular case, a computer or whatever, a washing machine or a computer or a or a vacuum cleaner or whatever, right? How do I make my machine, or a car, how do I make my machine respond to a particular reaction by giving it additional information? How do I train my machine to behave in a certain way? You take a young boy, right? As the boy grows, the boy is learning, and when the boy learns, or when the individual learns, the individual becomes smarter. We all agree to that, right? Nobody is a born genius, right? Of course, some of them are, and because of the way they are wired, but most people have to go through a process of learning to become intelligent, or to basically gain that knowledge. Similarly, what we are talking about here is how can I take a machine and how can I put the machine through a sequence of learning so that the machine becomes intelligent. So when I ask the machine about any question, I want the machine to respond back. So I need to train my machine. So how do I train that machine? How do I train a washing machine to behave in a certain way, right? Or how do I train my vacuum cleaner to behave in a certain way? Like, okay, there is a person in front of you, so take a left. How do I train my self-driving car to become intelligent? So that part is where we are going to get introduced. So artificial intelligence is this big motherhood, or the mother of everything, where you're trying to build intelligent systems. But there is a subfield of artificial intelligence which gives us the ability to learn from historical information. That is called machine learning. That field is called as machine learning. So what is machine learning doing? Machine learning is the field where you take historical information and you train your machines with historical data, and then you create some kind of a mechanism, a brain like mechanism inside these machines to learn this historical information, or to extract intelligence, extract knowledge from this historical data. That is machine learning, right? Machine learning is a field of computer science and a subfield of artificial intelligence that gives you a set of techniques to get the machine to learn historical patterns from data. Does that make sense, everyone? This is where, this is basically how your machine learning basically works. So let me maybe actually give you the slide. Right. So let's talk about this a little. Right. So what are the different types of different fields? So as I said, we have this broad field called as artificial intelligence, a subfield of artificial intelligence called as machine learning. So machine learning is a subfield of artificial intelligence that helps us learn patterns from historical data. Right? So learn knowledge or learn patterns from historical data. So machine learning is basically a field of computer science, and it is a bunch of techniques and algorithms slash techniques that help us capture this information. Now, over the years, what people have realized and what people have learned and felt was that machines are actually very good with dealing with certain kind of information, whereas as human beings, we are actually very good at dealing with certain type of information, right? So what do I mean by that? So let me give you a simple example. So if I give you, let's take a simple example. If I give you two types of information, so one, I give you the sales data of, let's say, all maybe a bunch of different stores. I give you sales transactions related data of a particular store, and I give you, let's say, 1 million observations here. Right? So I give you 1 million observations, meaning 1 million rows. You have information about the type of product which was purchased in a supermarket, the price of the product, and then blah blah blah. You have like a bunch of different information. As opposed to, let's say I give you, instead of 1 million, let's say even if I give you 100 observations, forget about 1 million. I just give you 100 rows. And then I give you another type of data wherein I give you 100 images. 100 images of different kinds of persons or different kinds of images. 100 different images. Now, you tell me, of these two in data sets, for us as human beings, is it easy to extract patterns from 100 photographs, or is it easy for us to extract patterns from 100 rows of Excel sheets, from 100 rows in an Excel sheet? Which of these two is easier for us to operate with? So if I give you an image and if I give you a bunch of rows, you're saying an Excel sheet is easier for us to work with? For you, human being, forget about the Excel sheets. I mean, forget about Excel. Imagine you don't have Excel, but imagine I just give you 1,000 observations or 100 observations of sales. And if you were to extract patterns without any external help, visually, if you were to just visually look at this data, using your visual capabilities, from where can you actually extract patterns quickly? Is it from the Excel numbers or is it from the images? The short answer is images, right? Images are much quicker. I mean, when we look at an image, it is easier for me to extract a pattern than when I look at like a bunch of numbers. Because when I look at bunch of numbers, then I'm lost because I don't know how to deal with these numbers visually, which is where we need tools, right? So deal with numbers is where we require tools because we are not wired to basically crunch numbers in real time. We are not good at doing something like that. Whereas images, photographs, audio, video, they're actually very good at dealing with that kind of information because then we are super fast at actually dealing with that kind of information. We are actually pretty good at extracting patterns or identifying anomalies. Or when I look at an image, I can quickly identify what if there's an anomaly. Or when I look at a song, I can quickly tell you when there is an issue with a particular song, or when somebody is not singing correctly, I can quickly tell you. The point is, we are very good as human beings. We are actually very good with dealing with unstructured data than structured data. This data is called as structured data, and there is unstructured data. Broadly, these are the two categories. There is like a category in between called semi-structured. Structured data is basically data in nice sheets, right? So you have rows and columns, relational database in some form. And these are like some examples, right? So you have sales information, which is nicely being captured in an Excel sheet or a whatever spreadsheet. Such data is typically referred to as structured data because data is properly structured, as opposed to unstructured data wherein you have media, emails, online reviews, videos, speech, sounds, music. All of that comes under unstructured data because this information cannot be stored in a certain format. You cannot store this information in a certain way, and for that reason we call this unstructured data. There is no structure to that information. The thing is, we as human beings, our human brain is very good at identifying patterns from unstructured data than structured data. But what we've observed is over the last few years, what we've been able to observe is there is a massive increase thanks to the advent of your social media and whatnot. We've started to observe a massive spike in unstructured data. Suddenly, we've started to see unstructured data go up exponentially. Right, there are images, there are videos, audios being posted online, blah blah blah. The volume of unstructured data just went up massively. So the machine learning techniques were originally built to deal with structured data. They work very very well with structured data. Meaning, if you have a nice Excel sheet like data, right? So you can basically pass this information into any of the machine learning algorithm, and the algorithm will be able to actually learn patterns from that particular thing, right? And it was pretty good. It was very, very good. Machine learning as a field was very good in that way. The problem is when the volume of unstructured data started to increase, when you started to have more and more images, right? And videos and audios and YouTube started to become like super popular. Since then, things have become a lot more complex. And we needed a set of algorithms that can basically deal with this unstructured data very, very well. So then came a subfield of machine learning called as deep learning, a subfield of machine learning called deep learning, which is responsible for extracting patterns from unstructured data. So the inspiration for deep learning is from a concept called as neural networks. And the idea of neural nets is to build algorithms that replicate a human brain like behavior. So they have said, okay, human brain is fantastic when it comes to dealing with unstructured data. So why can't we actually build models that can extract information from historical information just the way human brain does? So neural networks were built. They were also called as artificial neural networks. So artificial neural networks are basically, again, it's a computer science algorithm to which you can pass images or audio, video, and these neural network algorithms or deep learning algorithms basically scan through that information and become intelligent. Right? They become super intelligent by scanning through that all of that data. So deep learning is a subfield of machine learning. Remember, it's a subfield. It is not a separate field. It is a subfield of machine learning, which is responsible for solving these problems in an efficient fashion, especially unstructured data. So, like somebody is mentioning over here, yeah, Agarka is mentioning, yes, in chatbots, Google Dialogflow is one of the many things, but yeah, chatbots are one good example for how you could use historical text data to solve for problems. Yes, that's a very good example. Similarly, imagine you would also want to build models that can scan through images and identify what is there inside that particular image, or use these images to maybe do to generate captions from historical information, right? So if I have a piece of text or a particular image, I'd want to, let's say, generate a caption for that particular image, caption generation, or basically generating images based on caption. That also become very very popular these days. You must have heard of something called as Dolly. Dolly is basically like a new algorithm to which you can actually pass a sentence, and it would generate an image out of that particular sentence. So these are some very interesting examples of some very interesting abilities as far as machine learning and deep learning are concerned. Now, I have a couple of questions over here, so let me quickly respond back. Historical data can't predict unforeseen events, like which historic machine learning models are always machine learning or deep learning models or algorithms. Remember, garbage in, garbage out. So if you haven't passed it, if it hasn't seen events or drastic events like, let's say, COVID, um, or things like these in the past, then yes, there is no way algorithms will be able to predict any, or recession for that matter. Now we've seen recession a couple of times, so algorithms can actually predict recession as well to some extent right now. But broadly speaking, no. If there's a recession, or if there's, let's say, a COVID impact, or if there's a pandemic, or if there's anything for that matter, if there's a cyclone or a hurricane or whatever natural calamity, markets take a hit, and your algorithms will never be able to capture that because they haven't seen it in the past. So yeah, all algorithms are useless when something like this happens. They'll have to reset and reload when something like this happens. See, a simple way to answer that question is, if human beings cannot solve the problem, then there's no way artificial intelligence algorithms can solve that problem. So if human beings cannot identify the stock price of a particular stock in the next day, on the next day, and if human beings don't have the ability to take such external information into account, if human beings did not know, if we did not know, if a stockbroker did not know what the stock price is going to be next day, then there's no way an algorithm will be able to surpass, or the person will be able to do it, or the algorithm will be able to do it. So the bare minimum for an algorithm to work is for human beings to be able to actually be able to solve it in the first place. If human beings are able to solve, the algorithms will solve it equally, or at times even better than human beings. So the bare minimum is that we as human beings should be able to solve the problem. All right. So now we know that the field of artificial intelligence is basically a combination of two very interesting subfields. One called as machine learning, and machine learning has a subfield called as deep learning. So for all of you to actually learn deep learning, you need to learn fundamentals of machine learning. There is no two ways about it, right? So if you want to learn deep learning, great, a great decision to learn deep learning or neural networks or artificial neural networks. But if you want to learn deep learning, then you need to learn machine learning, because there are certain fundamental components of machine learning which you have to learn before actually learning deep learning, before actually getting into deep learning or neural networks. Like, for example, how do you build a model? How do you evaluate a model? How does an algorithm work? What are the fundamentals of an algorithm? What kind of data should we take? How should we eliminate, or how should we create new signals from data? What are the kind of what is the kind of data cleansing that we'll have to do? The tools that are required to do that data cleansing. All of that you have to go through. So your learning has to be linear, right? So you have to learn machine learning and then get into deep learning. If you ask me, can you actually leapfrog straight into deep learning? The answer is you can, but the learning curve is going to be extremely steep, because there's already enough to learn in the field of deep learning. You will struggle to basically learn deep learning if you don't learn machine learning or fundamentals of a machine learning. So that is fundamentally that is something which you all will have to understand. Okay, now let's keep going. Let's talk about this. So you have artificial intelligence, you have machine learning, you have deep learning, and then you have mathematics and statistics on the other side. All of this put together becomes a data science. So who is a data scientist? A data scientist is somebody who uses machine learning, deep learning, mathematics, and statistics to solve or to build artificially intelligent systems. That is a data scientist. A data scientist's end objective is to build AI systems, is to build artificially intelligent systems, or artificially intelligent solutions, which can help business, yeah, perform better, businesses, or help solve problems that are there out there. That is basically your deep learning, or in this particular case, data science. Now talking about what kind of skills do we have to pick up, right? So okay, I'd want to become a data scientist. I'd want to become a data scientist with expertise in, let's say, deep learning. So what are the skills that you'll have to pick up? So it is very difficult for us to separate the two and discuss, right? It is very difficult for us to separate machine learning and just focus on deep learning, because the two are almost, you know, deep learning is a subfield of machine learning. So there will be a significant overlap in terms of the tools that I'm going to talk about. So what are the different tools that one will have to pick up, right? So then there are different kinds of tools that exist out there. So let's talk about a few of them. Let's talk about some of those capabilities that are out there. So let's start with, I'm going to talk about firstly data processing. So what kind of tools do we often use to actually perform the data processing? But before that, even what programming languages do we have to work with? Typically, when we talk about programming languages and we talk about artificial intelligence and data science, are spot on. Python is often the preferred tool of choice. We often prefer Python. Python becomes the most important programming language that we often use. Now you can argue why Python, why not R, why not some of the other tools. Yes, there are like a bunch of different programming languages. So you could also use R. You can also use like a bunch of different algorithms that exist out there. To be very honest, it does not matter, right? So it does not matter which tool you'd want to work on. The preferred programming language today by almost 95% of the data scientists out there in the market is Python. The reason for that is Python has some very interesting abilities, unlike a lot of other tools. So number one, Python. All of us will have to go through some level of learning as far as Python is concerned. Under Python, as far as data processing is concerned, there are a bunch of different libraries that will help us perform these. So under Python, we have something called as NumPy, also referred to as numeric Python. So like for example, if you would want to, let's say, add a few numbers, you'd want to, let's say, perform some kind of a mathematical operation. You would want to, let's say, perform a matrix multiplication. You'd want to do some kind of a mathematical algebraic computation. You'd want to do optimization. All of those capabilities are available using NumPy. So NumPy stands for numeric Python. So any kind of algebraic operation or a mathematical operation that you'd want to perform, NumPy is like a sub library in Python that helps us accomplish this. Then you have another sub library called as pandas. So pandas is for data processing. Pandas is like another sub library under Python, which basically helps us perform operations using information such as, like for example, if you have a table, right? So if you would want to, let's say, join two tables, right? So you have sales information and then you have, let's say, customer related information, and you'd want to, let's say, join these two tables. So firstly, what pandas gives you the ability to view your data like an Excel sheet. Python by default does not have the data set like capabilities, or a Excel sheet like capabilities. What we have here is basically pandas is like an ability for us to or a capability that helps us combine these two data sets together. That is basically what we mean by pandas. And then we have another library, a very, very popular library by the name scikit-learn. Learn, scikit-learn, which is a library that helps us perform apply machine learning algorithms. Right. So what do I mean by machine learning algorithm? The algorithms into which you can pass some information, and then the algorithm scans through the data and extracts historical patterns. So scikit-learn has like a bunch of very, very structured machine learning algorithms that can go through information and capture capture insights from that particular data, right? So what are the different types of problems that you can solve using scikit-learn? So you could solve, broadly, there are two types of problems in machine learning. One is called as a classification problem and the other is called as a regression problem. What do we mean by classification and regression problems? So we have actually, classification problem is basically when you have, let's say, from your historical data, You have historical information of customers who have, let's say, purchased a particular product and not purchased a particular product, right? So maybe you are a car manufacturing company or a car dealership, and then you have information from your historical data that gives you the number of customers that you've reached out to, and of them which of them have actually purchased and which of them haven't purchased. So what you can do is you can pass this information into a machine learning algorithm, and the machine learning algorithm now, for any new customer, you can actually now identify if this particular person is going to purchase or not, right? We call such problems as classification, because given a new observation, you are classifying if this person is actually going to purchase or not. And this information over here can be age, the person's location, salary, and all of that. So all of these can be different sets of information that you can have over here for that particular person. Such kind of problems are referred to as classification problems. And then there is another type of problem called as a regression problem. A regression problem in this particular case simply means, so let's say you're trying to predict sales. So I have information, and then you're trying to predict, let's say, sales. So you're trying to predict a numeric quantity. So given a new observation, you're trying to predict a numeric quantity. Here you're trying to predict a categorical quantity, meaning you're trying to classify a given observation into a yes or no. In regression, we try to evaluate a numeric quantity, like I'm predicting sales, or I'm predicting, let's say, rainfall, or I'm predicting the yield of a particular crop. I'm predicting, let's say, the stock price. All of these are numeric quantities, like numbers is what I'm trying to predict. So wherever I'm trying to predict a numeric quantity, we call it as a regression problem. Wherever I'm trying to predict a categorical quantity, we call it a classification problem. So all these types of problems, right, can be solved using machine learning. So, and scikit-learn in Python give us the ability to actually solve all of these problems. So a typical workflow would look like this. So what you would do is you would extract your dataset from wherever source you have, use pandas to maybe create the right kind of dataset. You might combine multiple datasets and create like a final dataset with how many ever rows and columns that you want, and then use this particular dataset and pass it into one of the scikit-learn machine learning algorithms, and then build your final ML algorithm, ML model. We call it as a machine learning model. That is the typical workflow. Okay. Now where does deep learning come in over here? This is all great. Now, what if instead of fitting your traditional machine learning algorithms, I would want to solve for a deep learning problem? I want to, let's say, fit a deep learning solution to this. What do I mean by that? So imagine I would want to, let's say, imagine in this particular case, I would want to build a image classification algorithm. I'm still solving a classification problem, right? I'm still solving a classification problem. Given a particular image, I'm trying to classify if this particular thing is a cat or a dog or human being, right? So I'm still classifying this image, saying it is a cat or dog or human. But here my data is not a table, is not a structured data, is not an Excel sheet. Here my data is unstructured data. So in such cases, whenever you have unstructured data and whenever you have more, it's not that you cannot use deep learning with structured data. You can also solve structured data problems. But whenever you have unstructured data, deep learning becomes all the more relevant, right? So what you do is you then pass this data into, should you pass it into scikit-learn? Well, in this particular case, instead of using the scikit-learn, so we spoke about under Python, we spoke about multiple algorithms. One is NumPy, the other is pandas, and then the other is the scikit-learn. Then we would also have other libraries such as TensorFlow. So you would then pass this into TensorFlow. TensorFlow is while this is an ML library, this is a deep learning library. So you pass it into TensorFlow, and then what TensorFlow helps you do is TensorFlow helps you actually solve these classification problems into one of these different classes that you want. a cat or a dog or a human being, you can then actually solve the problem using some of that, right? So that is as far as your TensorFlow is concerned. So you have NumPy, you have Pandas, scikit-learn, and TensorFlow. Now you can ask, hey, is TensorFlow the only deep learning framework or a Python library that is available? The answer is no. There is actually a bunch of different libraries that are available here, but the two popular ones are these. One is TensorFlow and the other is PyTorch. So these are the two most popular TensorFlow libraries that are deep learning libraries that exist out there. You can pick up whichever one that you're interested in and then solve your problems using those model or using those capabilities, using those libraries that you want, right? So this is typically how you would go with your learning curve. Now, in addition to this, one or some of the other learnings that you will also have to go as a data scientist within Python itself. We would also be learning some additional visualization libraries, such as you could learn matplotlib, which is for visualization. So imagine you want to represent an information in a curve or in a chart, or you'd want to create a bar chart or a pie chart or whatever. Matplotlib is like the plotting library. This is for visualization. This is the typical learning curve that you will have to go through to become a data scientist, or to become a data scientist with a specific expertise in let's say TensorFlow or Python or into deep learning. These are the tools that you will have to pick up. In addition to these are the tools, and then the most important thing, which is the skills. Under skills, you need to pick up the following skills. You need to pick up basics of statistics. You'll need to learn machine learning, right? And then you need to learn deep learning. You need to learn fundamentals of statistics. I wouldn't say you need to learn a lot of them. You need to learn fundamentals of statistics, uh, machine learning in depth, and deep learning also in depth. So if you can learn the skills that are required and the tools that are required, this would stand you in a decent shape to become a data scientist. Of course, there are some additional skills also that are required, some supporting skills. I can just maybe supporting tools. One of them is SQL. SQL is basically a language that will help you uh, query information from databases and things like that. So SQL will become, let's say, another very, very important additional skill for you to pick up. If you really want, you can also pick up one of the, if you want, again, this is not mandatory, any cloud platform, right? So like let's say an Azure or Google Cloud or whatever, that's totally up to you. I let you I mean, this is not mandatory at all. This is not mandatory at all. This is a mandatory skill in some form. It's supporting, but it is mandatory. This is not mandatory at all. But everything that I've mentioned here and here, you are expected to be fairly good at these skills before you even apply for a job as a data scientist anywhere. Okay, so these skills put together would make you a data scientist. Thank you so much for sparing your time, and I hope you'll enjoy the session. Or I hope the session was useful for all of you. And I wish you all the best for your AI journey. Wherever you are, I'm sure you'll find applications for artificial intelligence. Learning AI is definitely very rewarding. Not because the AI as a space, not because I am in the AI space, but also because, but more so because AI is actually applicable, pretty much ubiquitous, right? Pretty much, you can actually apply it everywhere you can think of. So thank you so much, and all the best.